Welcome back to QHSE Talks, where safety knowledge is translated into practical understanding for professionals working in quality, health, safety, and environmental management. In this episode, we're opening Chapter 4 of David Yates's Safety Professionals Reference and Study Guide, a chapter that forms the regulatory backbone of the safety profession. This is where the conversation moves beyond theory and into the legal framework that governs how workplaces are expected to operate and how safety professionals are held accountable. This chapter brings everything back to first principles. It starts with the law that gave meaning to modern workplace safety in the United States, the Occupational Safety and Health Act of 1970. That single piece of legislation established a national expectation. Work should not expose people to unacceptable risk, and employers carry a legal responsibility to prevent serious harm. From there, the discussion expands into how that law is applied in practice. It explains how OSHA functions as a regulatory body, how inspections are initiated, how priorities are determined, and what actually happens when a compliance officer walks through a facility. These are not abstract concepts. They are real processes that safety professionals must understand to effectively manage risk, respond to inspections, and protect their organizations. The chapter also highlights a critical idea that separates compliance-driven safety from professional safety judgment, the difference between broad cross-industry requirements and standards written for specific industries. Understanding that distinction helps safety practitioners apply the right controls in the right context, rather than treating regulations as a one-size-fits-all checklist. Equally important is the emphasis on employer responsibility when no specific rule exists. The message is clear. The absence of a standard does not mean the absence of responsibility. Employers are still expected to recognize serious hazards and take reasonable steps to control them. That concept is foundational to how OSHA enforces safety and how safety professionals are expected to think. Finally, the chapter grounds all of this in reality by referencing the standards we deal with every day: chemical hazards, energy control, confined spaces, PPE, respiratory protection, and fall hazards. Together, they illustrate how legal intent becomes enforceable requirements on the job site and on the plant floor. This episode sets the stage for understanding not just what the rules are, but how and why they are applied, and what that means for anyone responsible for protecting workers.
Oh, absolutely. Its purpose was so clear: to assure every working person in the nation safe and healthful working conditions.
Now, the scope of coverage is huge, but it's not absolutely everyone, right, who is actually subject to this law.
That's a great question. The coverage is designed to be nearly universal, at least across the private sector. So it covers most private employers and their workers in all 50 states, D.C., and other U.S. territories.
But there are some mandatory exceptions?
There are. The Act does not apply to the self-employed, for example, or to immediate family members of farm employers.
Okay.
And it also doesn't apply to workplaces that are already protected by other federal agencies.
So, like mining, for instance.
Exactly. If you're working under the Federal Mine Safety and Health Act, or, say, the Coast Guard, you're not covered by OSHA. And crucially, the OSH Act allows individual states to set up their own programs.
Right, the state plans.
Yep, an OSHA-approved state plan. And where one of those exists, that state's jurisdiction often takes precedence for private sector compliance.
That dual system, federal OSHA versus the state plans, that's a layer of complexity every professional has to master.
It really is.
Now, when we talk about the specific regulations that come from the Act, the thousands of pages of rules, we have to categorize them. The source material makes a really sharp distinction between horizontal and vertical standards.
And that professional distinction really dictates which rulebook you open first. It's a fundamental concept.
So what does it mean for daily compliance?
Well, think of horizontal standard as general and widely applicable. They cut horizontally across pretty much all industries.
So these are things like rules for walking and working surfaces or fire protection.
Perfect examples: electrical safety, fire protection, working surfaces. If you run an office building, a factory, a warehouse, you are primarily governed by those horizontal standards.
There's sort of the safety rules for fundamental human and machine interaction, no matter what you're actually making.
That's a great way to put it. Then conversely, you have vertical standards,
And these are the specialized ones.
highly specialized. They're applicable only to a specific, defined industry where unique hazards mean you need custom rules. The classic example is construction.
29 CFR, 1926.
That's the one. For instance, the rule that mandates fall protection for construction work, 1926.501, that doesn't apply to general industry unless the work you're doing in general industry sort of mimics construction activity.
So knowing the difference is vital. You can't just pick and choose.
No, and it's a common compliance error. Applying a horizontal standard where a vertical one exists, or vice versa, that's not going to hold up during an inspection.
Okay, here's where it gets really interesting, and this is the foundational concept that underpins all safety law, whether a specific standard exists or not, the General Duty Clause.
The ultimate safety net, Section 5A1 of the OSH Act.
Tell us about the profound legal power of this clause.
The General Duty Clause, or GDC, is the legal requirement that closes all the regulatory gaps. It mandates that every employer must furnish to each employee a place of employment which is free from recognized hazards that are causing or are likely to cause death or serious physical harm.
So even if OSHA hasn't written a specific rule for, say, a brand new type of industrial robot,
Right, a hazard that no one even conceived of when the standards were written.
the employer's still on the hook. They're still liable if they don't control that danger.
That is the critical takeaway. It forces employers to look beyond the literal text of the standards and to continuously assess and mitigate the specific dangers in their own workplace.
And that term recognized hazard is key, isn't it?
It's crucial. And it doesn't mean the employer has to stand up and say, yes, I admit this is a hazard. A hazard is legally recognized if the industry generally recognizes it.
So consensus standards, things like that.
Exactly. Or if the employer's own testing or hazard analysis recognizes it. Or, and this is a big one, if the hazard has been cited by OSHA before, even at a different company.
Wow, so that demonstrates there's an existing awareness of the problem.
It does. It forces professionals to use consensus standards, manufacturer warnings, and all that testing data as legally binding benchmarks for safety.
That just elevates risk assessment from, a best practice to an absolute legal necessity.
It really does.
Let's move to the practical duties the Act puts on the employer, beyond just the GDC. It's a pretty comprehensive list of mandates.
It is. The employer's duty is multifaceted. It touches on nearly every aspect of the organization. They have to systematically examine workplace conditions for compliance with all the applicable standards.
So doing their own audits and inspections.
On a routine basis, yes. And they have to actively minimize or reduce the hazards they find, preferably using the hierarchy of controls.
Always trying for engineering controls before just handing out PPE.
Always. And, crucially, they must provide all the required training as mandated by specific OSHA standards, like training on lockout, takeout, or confined spaces.
And the administrative and communication requirements are just as non-negotiable, right?
Oh, absolutely. Employers are responsible for keeping all the OSHA-required records, like the OSHA 300 logs, and keeping them for the mandated time.
And there's also a profound responsibility about employee records.
Yes, providing employees access to their own medical and exposure records. Data on noise, chemical exposure, that sort of thing. It ensures employees have the information they need about their own long-term health risks.
And then there's the visible stuff.
Right. Using color codes, posters like the OSHA job safety and health poster labels, and signs to consistently warn people about potential hazards.
Now, we always focus on employer duties, but what about the employee side? Does the OSH Act have reciprocal responsibilities?
It does, but it's a bit different. The OSH Act primarily places the liability on the employer. However, Section 5B of the Act does state that each employee shall comply with the safety and health standards.
But OSHA doesn't usually cite employees, right?
Generally, no, they don't fine employees directly, but the enforcement system implies these duties. Employees have the right to request inspections and refuse work under imminent danger, but in return, they are expected to follow the rules, wear their PPE, and participate.
So employee noncompliance could be a factor in an employer's penalty, but it doesn't remove the employer's responsibility.
Exactly. It might be a factor in penalty reduction, but the ultimate legal responsibility for a safe workplace remains squarely with the employer.
Okay, so the OSH Act sets the law. The enforcement process is what brings it to life. Let's walk through a standard OSHA inspection. This is where the paper rules become, extremely real.
It's a highly formalized process, and it usually follows a specific priority sequence. First up is always imminent danger situations.
Makes sense.
Second, fatalities or catastrophes, which they define as hospitalizations of 3 or more employees. Third, worker complaints or referrals. And then finally, you have the programmed inspections that target high-hazard industries.
And the process itself involves a few key steps.
Yes. An opening conference, a walk-around inspection, and then a closing conference where the inspector discusses any apparent violations they found.
So once violations are found and citations are issued, the area director sets the penalties. And the source material really emphasizes some specific policies on how those penalties can be reduced.
It does. OSHA's penalty system is designed to, incentivize good behavior, but punish intentional malice. So reductions are possible for small employers and for those who can demonstrate verifiable good faith.
And good faith isn't just saying you tried, is it?
No, it means you had a genuine, ongoing safety and health program. You provided training, you were actively trying to comply. The existence of a robust safety program, even if it had a flaw, can lead to a reduction.
And the gravity of the violation matters too.
It does. The penalty for a serious violation can be reduced based on the gravity, how likely an injury was, and how severe the harm would have been.
But the moment an alleged violation crosses that line into willful, everything changes.
Oh, that's an absolutely crucial point.
Yeah.
A willful violation is when an employer either knowingly disregarded a safety requirement or just acted with plain indifference to employee safety.
And if a citation is designated as willful?
You forfeit any claim to a good faith adjustment. It dramatically increases the penalty. This is why documenting every reasonable safety measure is so essential. It builds a defense against that willful designation.
So the citation is delivered, then comes the moment of truth. The appeal process. This administrative detail is probably the most high-stakes deadline in all of safety compliance.
It really is. The timing is completely unforgiving. If an employer decides to contest the citation, the abatement period, or the penalty, they have a critically short window.
How short?
15 working days. From the moment they receive the citation, they have 15 working days to notify the OSHA area director. And that notification must be in writing.
15 working days, that's basically just 3 calendar weeks. You can't afford a single misstep.
Not one. Because if you miss that deadline, even by 1 day, the citation and the penalty automatically become a final order of the OSHRC, the Review Commission.
With no chance for further appeal.
No chance for further administrative appeal or negotiation. It's legally binding. The hazard must be abated. The penalty must be paid, period.
And the formality of that appeal matters. A quick email or a phone call saying, hey, we disagree, that's not going to cut it.
No. It has to be a written notice of contest.
Mm.
It doesn't have to be a super formal legal document, but it has to be in writing and it has to clearly identify what you're contesting. Is it the violation itself? The time you're given to fix it? Or just the penalty amount?
So clarity, in writing, on time, non-negotiable.
Absolutely.
And it's important to note, employees have appeal rights too, but they're a bit different.
They do. Employees or their representatives usually appeal because they believe the abatement period is unreasonable. They think the hazard should be fixed faster than OSHA allowed. But the employer's process starts and ends with that notice of contest.
Before we move on, let's touch on the metrics OSHA uses to quantify safety performance, like the TCIR and DART rates. For our audience, why are these calculations so important in this whole regulatory landscape?
Well, these rates, the total case incident rate and the days away, restricted, or transfer rate, they're the regulatory yardsticks. They're what OSHA and increasingly investors and partners use to judge how a company is doing on safety.
So TCIR is sort of the big picture.
Yep. TCIR captures the total number of recordable injuries and illnesses per 100 full-time workers. Anything that required medical treatment beyond simple first aid usually gets counted here.
And DART is the subset of that, focusing on the really serious stuff.
Precisely. The DART rate only uses those cases that resulted in days away from work, restricted work, or a job transfer. So it's often seen as a better indicator of how you're managing severe hazards.
And companies really watch their DART rate because a high one can trigger more attention from OSHA.
It can trigger targeted inspections, and it signals that there might be a systemic failure in how you're controlling your most serious hazards.
And one last critical distinction here, an injury status for OSHA versus its status for workers' comp. People confuse these all the time.
They do, and they are entirely separate legal frameworks. An injury might be non-reportable under OSHA's rules. Maybe it just needed a tetanus shot and some basic wound care. But it could still be legally compensable under state workers' compensation laws.
So the criteria are totally different.
Completely distinct. Safety pros have to manage compliance for both at the same time. Just because an injury isn't an OSHA recordable doesn't mean the company is off the hook for its state comp obligations.
The mechanism of enforcement is critical, but what happens when that enforcement shifts to these highly specific global hazards, like the chemicals we handle every day?
Well, that brings us right to the Hazard Communication Standard, HCS, 29 CFR 1910.120.
Let's start with just the immense scope of this standard.
HCS is a complex three-part chain of responsibility. It's designed to make sure chemical safety information follows the product from its creation to its final use.
Okay, so break that chain down for us.
First, the chemical manufacturers or importers have to classify the hazards of the chemicals they produce or bring in. It's a very detailed technical process.
So they're the linchpin of the whole system.
They are. Then, distributors have to ensure that all this information, the labels, the safety data sheets, gets transmitted down the supply chain.
Yeah.
And finally, all employers have to provide that information to any exposed employee.
Through a written program, labels, SDSs, and training.
Exactly. Now, employers who only use chemicals, they don't produce them, they still have a huge responsibility. They have to focus intensely on that workplace program and effectively communicating the information to their workers.
Now, HCS covers almost everything, but there are some important exemptions, right?
There are. The standard doesn't apply to specific things regulated by other agencies or to common articles.
Like what?
Things like wood or wood products, food, drugs, cosmetics, hazardous waste regulated by the EPA, or articles, which are manufactured items that have a specific shape and don't release more than a tiny amount of a hazardous chemical under normal use.
So the heart of the employer's commitment is that written hazard communication program. What are the essential mandatory elements that have to be in that document?
This document is the employer's blueprint for chemical safety. It must include a few key things. First, a list of all hazardous chemicals present, identified in a way that directly links to the corresponding SDS.
Okay, what else?
Second, it has to describe the methods the employer will use to inform employees of hazards from non-routine tasks.
So things like cleaning out a storage tank or opening a valve that hasn't been touched in years.
Exactly. And the third mandatory element, which is critical in so many industrial settings, is about unlabeled pipes.
Ah, yes.
The program has to detail how you're going to inform employees about the hazards of chemicals in those unlabeled pipes. And finally, for multi-employer work sites, it has to explain how the host employer will get that chemical info to contractors and their employees.
That failure to communicate with contractors during non-routine tasks seems like a massive failure point.
A huge one.
Now, this standard went through a massive overhaul to integrate the globally harmonized system QHS. Why was this global effort even necessary? What problem was it trying to solve?
Well, before GHS, chemical safety information was a mess, a total cacophony of standards.
Every country had its own system, its own symbols.
Right. The EU, the US, international bodies, they all use different definitions of flammable, different document formats. It was a nightmare for global trade and a huge risk to human health.
So the objective was to create one single internationally comprehensible system.
Exactly. A single reliable framework that works across language and jurisdictional boundaries.
And GHS harmonization provided two major unified elements.
It did. It standardized both the highly technical hazard classification criteria, so what makes something a Category 1 explosive, and the universally recognizable communication tools.
Which are the standardized labels and the mandatory safety data sheets.
That's it.
Okay, let's break down those GHS labeling elements. What must be on that container label?
4 elements are mandatory: pictograms, signal words, hazard statements, and precautionary statements. The power of the GHS label is in its rigid, predictable structure.
The pictograms are those standardized symbols in the red border diamonds. But we have to talk about the precedence rules for health hazards. Why do those exist?
They exist to maximize clarity and, frankly, to prevent clutter. If every single little hazard required its own pictogram, the label would be just overwhelmed with symbols.
So the rules make sure the most severe warning takes priority.
And the less severe, redundant symbols are eliminated.
Give us a specific example of that.
The source material highlights 3 key rules for health hazards that involve the exclamation mark pictogram, which is generally for less severe hazards like skin irritation.
Okay.
So first, if the skull and crossbones pictogram for acute toxicity applies, the exclamation mark should not appear. The severe warning just subsumes the lesser one.
Got it.
Second, if the corrosive symbol applies, again, the exclamation mark shouldn't appear for skin or eye irritation. Corrosivity is the higher level hazard.
And the third one?
If the health hazard symbol appears for something like respiratory sensitization, the exclamation mark should not appear for, say, skin sensitization or general skin irritation. The goal is to keep it clear and focused on the biggest threat.
That's crucial for professionals. If you see the skull and crossbones, you know it's bad enough that the lesser warning is just redundant. What about the signal words?
GHS simplified this down to just two: danger and warning.
Danger for the more severe hazards.
Right, typically categories 1 and 2 within a hazard class. Warning is for the less severe ones. And the same logic applies. If danger is on the label for any hazard, the word warning should not appear at all.
And the remaining elements, the hazard and precautionary statements, they provide the text, the actual instructions.
They translate the symbols into action. Hazard statements are standardized phrases that describe the nature of the hazard, like fatal if swallowed. Precautionary statements are the critical P phrases that recommend measures to prevent adverse effects, like wear protective gloves.
Let's transition to document that holds all this data, the safety data sheet, or SDS.
Yeah.
You mentioned the old HCS allowed any format for the MSDS.
And that was the international headache GHS solved. GHS now requires the SDS to have a specific fixed sequence of 16 sections.
And that sequence is mandatory worldwide.
It is. So a safety professional knows that Section 9 is always physical and chemical properties, and Section 15 is always regulatory information, no matter where that chemical came from.
Highlight a few sections that are critical for, say, incident response.
Well, beyond the first few sections on identification and composition, Sections 4 through 8 are crucial for immediate safety. Section 4 is first aid, Section 5 is firefighting, Section 7 is handling and storage, and Section 8 is exposure controls and PPE.
And for shipping.
For the supply chain and emergency responders, Section 14, transport information, is vital. It has to have the UN number, the proper shipping name, and all that.
Now let's get into the technical weeds, because the shift to GHS wasn't just about new labels. It actually changed how hazards were defined and categorized.
Yes, the changes introduced far greater nuance. Take explosives, for example. The old HCS just lumped them all into one category.
Explosive.
Pretty much. GHS introduced 6 specific hazard divisions, from Division 1.1, a mass explosion hazard, all the way down to 1.6, extremely insensitive articles. This gives you a much more detailed risk assessment for storage and transport.
And what about a really common hazard like flammable liquids?
HCS had 2 basic categories. GHS expanded that to 4 hazard categories based on specific flash points and boiling points.
So it's much more granular now.
Much more. Category 1 is for liquids with extremely low flash points and boiling points, the highest risk. It becomes progressively less severe all the way to Category 4, which still requires the signal word warning. It forces better, more specific control measures.
And finally, let's look at carcinogens. The old HCS often just relied on lists published by groups like IRRC or NTP. How did GHS change that?
GHS moved from simple listing to a system based on harmonized criteria and the weight of evidence. So while those lists are still important reference points, GHS classification now requires a formal, systematic review of reliable human and animal data.
So it's a move toward technical justification rather than just being on a list.
Exactly. The substance is formally compared against the GHS criteria to determine if it's a Category 1A, known human carcinogen, or 1B, presumed, or Category 2, suspected.
One final point on the SDS. Confidential business information, or CBI. A manufacturer needs to protect its formula, but a doctor in an ER needs to know what they're treating. How does the regulation balance that?
That's the classic conflict between intellectual property and life safety. The rules for CBI do take priority, meaning a company doesn't have to list the specific percentage of a trade secret ingredient on the public SDS.
But that non-disclosure has a limit.
It does. It ends when human life is at risk. Disclosure of that confidential info is required immediately to health professionals in a medical emergency.
And that medical professional is then bound to secrecy?
They are. They have to maintain the confidentiality of that information. The system is designed so that proprietary protection is always secondary to emergency medical response.
That complexity really sets the stage for how we manage specific, high-energy, high-risk hazards. So let's move into a few of the most highly cited standards, starting with control of hazardous energy, or lockout-cugout.
LOTO, 29 CFR 1910.147. This standard saves thousands of lives by preventing unexpected startup.
And to understand it, we have to start with the technical definitions that dictate when it even applies.
The precision of the definitions is everything here. The goal is to prevent the release of energy during servicing or maintenance. So 3 key terms define the application. First is energized.
Which means it's not just plugged in.
Right. It means it's connected to an energy source
Mhm.
or contains residual or stored energy, like a compressed spring or a hydraulic accumulator. Then you have servicing or maintenance, which were activities where an employee could be exposed to that unexpected startup.
And the term that often determines the whole program. Capable of being locked out, what does that technically mean?
An energy isolating device is capable of being locked out if it has a permanent way to attach a lock-a-hasp, a built-in mechanism, something.
And if it doesn't?
If it doesn't have those features, it's only considered capable of being locked out if you can achieve lockout without having to, dismantle, rebuild, or permanently alter the device. This often forces employers to upgrade old equipment that can only be tagged out.
Because tagout alone is less protective.
Much less. It's only permissible under very strict conditions.
The strength of any LOTO program really hinges on its training. What does that mandatory training have to ensure?
The training isn't just an info session. It has to ensure employees fully understand the purpose of the energy control program and, more importantly, acquire the skills for safe application, use, and removal of the controls.
So what's the mandatory content?
It has to include recognizing all the hazardous energy sources: electrical, mechanical, hydraulic, thermal, the type and magnitude of the energy, the specific isolation methods, and the absolute prohibition against trying to restart equipment that's locked out.
And retraining is a big part of this too, because things change. What triggers mandatory retraining?
A few things. A change in job assignments, so an employee is working on a new type of machine. Second, if the equipment or processes change in a way that creates a new hazard.
Okay.
Third, if the procedures themselves change. And finally, and this is the enforcement trigger, if a periodic inspection reveals that the employee doesn't really know what they're doing or the program has flaws, retraining is required.
Yeah.
And it all has to be certified and documented.
Let's pivot now to a major health standard that requires intense control. Respirable crystalline silica, or RCS. This is an invisible but absolutely lethal hazard.
It is. And RCS exposure is a pervasive issue. It crosses a lot of industrial boundaries. Basically anywhere rock, concrete, sand, or masonry is disturbed.
So things like manufacturing stone countertops, abrasive blasting.
Sawing brick or concrete, grinding mortar. The common element is disturbing silica-containing materials, which releases those tiny crystalline particles that can get deep into your lungs.
And the regulatory limits are incredibly strict because the diseases, silicosis, lung cancer, are so severe. What are the key exposure limits professionals need to have burned into their memory?
They are very low. The permissible exposure limit, the PEL, is just 50 micrograms per cubic meter of air, as an 8-hour time-weighted average.
50 micrograms, that's tiny.
It is. But the standard also introduced a mandatory trigger point called the action level, or AL, which is half the PEL,
Right.
25 micrograms per cubic meter.
And crossing that action level triggers a whole new set of requirements.
Mandatory requirements for air monitoring and often the immediate implementation of controls.
To manage that risk, employers have to develop a very specific document. The written exposure control plan. What does that plan need to contain?
This is the employer's non-negotiable blueprint for silica compliance. It has to list the specific tasks that involve exposure, and then it has to detail the engineering controls, work practices, and respiratory protection used for each of those tasks.
And it also has to cover housekeeping.
It does. It has to describe the housekeeping measures used to limit exposure, and that means explicitly prohibiting things like using compressed air or dry sweeping, which just aerosolize the dust. You have to favor wet methods or HEPA vacuums.
Okay, next let's cover personal protective equipment, or PPE. This seems straightforward, but the regulation's true power is in what you have to do before you even hand out the equipment.
Absolutely. The standard mandates that PPE must be provided, used, and maintained where hazards are present.
Yeah.
But you can't just guess or hand out safety glasses to everyone. The regulatory foundation is the hazard assessment.
Which has to be performed and documented.
It does. The employer has to perform a comprehensive hazard assessment of the workplace to identify all the hazards that would necessitate PPE.
And that assessment has to be certified in writing.
Yes. A written certification that the assessment has been performed with the date, the name of the person who did it, and the workplace that was evaluated. No documentation, no compliance.
Finally, let's briefly touch on fall protection. This is a huge one in construction, but it's also critical in general industry. What is the key measurement that triggers the duty to provide protection?
The employer must first determine if the walking working surface is structurally sound. Then the mandated protection guardrails, safety nets, or a personal fall arrest system is triggered when that surface is 6 feet or more above a lower level.
6 feet, that's the magic number.
6 feet is the critical regulatory threshold. Failure to provide one of those primary systems at or above 6 feet is a direct and usually serious violation.
So what does this all mean for you, the learner, who is trying to master this material?
Well, we've traced the entire regulatory chain of command. We've confirmed that every professional has to operate under that non-negotiable legal safety net of the General Duty Clause.
Which forces you to mitigate all recognized hazards, even if there isn't a specific rule for them yet.
Exactly. We detailed the absolute urgency of those administrative deadlines, especially that strict 15-working-day notice of contest. And we dissected the detailed fixed language of chemical safety through GHS.
You know, what this deep dive really shows is that compliance isn't a passive activity. It is an integrated administrative and technical process.
It is. Whether it's ensuring your written HAZCOM program addresses unlabeled pipes or making sure that ELDO retraining is triggered every time a new machine is installed, success really hinges on mastering these precise nuances.
The regulations, from the specific controls in the silica standard to the criteria that define a willful violation, they're really just detailed blueprints.
They are. They're designed to standardize safety communication and to enforce a certain level of thoroughness in protecting lives. They formalize accountability, whether it's through a metric like the DART rate or through those unforgiving appeal deadlines.
Which raises an important question for you, the learner. If knowledge is power and safety regulations are essentially formalized, technical knowledge of risk, how might proactively applying these standards, not just checking boxes to avoid a penalty, but truly integrating the intent of the General Duty Clause, fundamentally change how we measure success beyond simple compliance?
How do you transition from being a rule follower to being a genuine risk eliminator? That's something for you to mull or explore on your own.
Thank you for joining us for this deep dive into the regulatory core of safety.
We hope you feel a little more well-informed and a lot more prepared. We'll see you next time.